Hello and welcome to another ER and relational model video. In this video we're going to be focusing on how to create relational models from ER diagrams. So far we've had a look at how do we make ER diagrams, namely how we can construct attributes, relationships, plus inheritance slash hierarchies for our diagrams. And all of these in our ER diagrams fall under the stage we call conceptual model. So this first stage. What we're focusing on for our next few videos is in this stage, the relational model. So how we can take our ER diagram and translate it into a relational model. As an example, let's have a look at an ER diagram over here. We've got a many-to-one relationship between student and teacher, and the student and both entity sets contain multiple types of attributes. For example, over here in the students, there's a composite attribute. We have a multi-valued attribute, as well as just a single value attribute with the ZID. This video will focus on how we can translate attributes into attributes within a relational model. So as an example, this ER diagram, by the end of the process, we want to be able to translate it to something like this. So a relational model will look more like the end product of our database. Let's now have a look at how we can translate regular entity types. We have here an ER diagram representing the course. To translate a course entity set, we just first write down the name. And then the single valid attributes turn into attributes for the relational model. So here we can write course code and also course name. And we draw a box around it. And we separate both attributes. And so now we have two attributes for this relational model. And like how we called this an entity set, we call this a relation. Hence the name relational model. Now let's have a look at composite attributes. So here we have a factory entity set with the composite attribute location, which is made up of three extra attributes, which is street, postcode, and state. For composite attributes, all we need to do is do what's called a flattening. Before we do that, let's first create our relation factory. So here I've already started already. So we've created our relation factory. And let's add in some attributes. So flattening is really just taking each of these attributes and putting them as attributes within the relation. So we just write down street, postcode, and state. Draw a box around all three of these and separate them. So we have, and that is what we mean by flattening. So composite attributes, we just take each of the attributes and put them as individual attributes within the relation. Now before we move on, like in ER diagrams, how we underline attributes to notify a key. For a relation, we do the same thing. So over here for the course, we'd underline the course code. Now because this is quite a mouthful to say, and we want to use the course code quite often, what ends up happening is instead of a course code, we can still have a course code actually. But in this case, I'm just going to change it. We can write course ID. And we underline that as our primary key. And to make it even shorter, we can just write even CID for course ID. Those are some of the convention you'll see when people use keys for a relation. And in this case, since the CID will uniquely identify the course, we call this the primary key. So down here, the factory relation does not have a primary key so far, so we can add one ourselves. But if we need to add new stuff to our factory relation, that might mean that our ER diagram is incomplete and we need to revisit it and have a look at it even further. Our final attribute to look at is a multi-valued attribute. Here we have a weighted ID and a multi-valued attribute of orders, which means we have a list of orders such as, order 2, 3, 4, 5, etc. How will we represent the multi-valued attribute? Well, let's have a look at a few examples. Our first example we can try is, let's say we have the weighted ID over here. And we could just represent the orders directly as a list within the relation. So we'd end up with something like waiter ID 3, and then we have order 4, 1, 5. And every time we want to add an order, we just add to the list. And every time we want to remove an order, we just remove from the list. The way databases are implemented makes this type of structure really inefficient. We'd have to query from our database, and then within our application, manually sort through ourselves this list and delete from it and add to it. Once we start having to uh, filter the data ourselves from the database, we've done our design. We've done our design incorrectly. So we're not going to go with this way. Another idea we could have is we could have a waiter and a waiter ID, and for every order we just have a new column. So there's order 1 and order 2. Every order we just create a new column. This is even worse than before and extremely inefficient if we actually do this in practice, because adding a new column locks the database, which prevents any new orders or even sometimes reading from the database from happening. So we don't want to add new columns every time we make a new order, since we're frequently adding new orders. So those two ideas are out of the question. Okay, what about just having the waiter ID and an order, and every time we get a new order, we just add a new row? So here we have waiter 1, order 2, waiter 1, order 3, and every time we get a new order, we just add a new row. Now this is fine, this works well, except for the fact that we will have a lot of redundant data, all these ones. And especially if the waiter not only just has a waiter ID, we have a bunch of other data along with it. We're going to be copying and pasting a lot of data. So we're going to have a lot of duplicates within this model. So this way, while better than the others, is also not satisfactory. The way to deal with multivalued attributes is just to take the multivalued attribute and create a new relation. So here's our waiter with the WID. Let's draw a box around it. And they might have other other attributes as well. And then we take our order, add the order ID. So let's add OID. And then we need a way of referencing the waiter. So then we just use the waiter ID. And there we go. And that's how we model a multivalued attribute. We just create a new relation for the multivalued attribute, and we add the primary key of our initial relation. And in this case, both the order ID and the waiter ID will act as the primary key for this new relation. Okay, for derived attributes, we don't need to model them within our relations. And relationships, we'll have a look at our next video. So in summary, entity sets and types from the ER diagram turn into a new relation. Regular attributes just turn into normal attributes for the relation. Composite attributes are flattened. And multivalued attributes, we create a brand new relation and we add the primary key connection as seen as above. And in fact, I've forgotten to do one thing over here. We put an arrow towards the primary key we're referring to. And thank you for watching this video.